Hi, this is Sammy again. My grade 11 students are doing graphing reciprocal functions or rational functions. So I thought I'll throw in a question in here and show you how to graph reciprocal functions in the easiest way possible. Okay, so to be able to graph this, I think with rational functions, we have to find out if we have a vertical asymptote, if we have a horizontal asymptote, then find your y-intercept or your x-intercept. And from that, that would be good enough to give you a guideline on how to graph reciprocal functions. So first of all, vertical asymptote. How do you find the vertical asymptote? The vertical asymptote is the x value that would make the bottom 0. So it's always the x value that will make the bottom 0. That's what the vertical asymptote is. So basically, it's x plus 2 equals 0, and therefore x must be negative 2. So your vertical asymptote is at negative 2. Now, how about the horizontal asymptote? The horizontal asymptote, always if the degrees are the same on top, on the bottom, like here is x to the 1 and x to the 1. If the degrees are the same on top, on the bottom, then you look at the coefficient of the top x and the coefficient of the bottom x, which is 2 over 1, and therefore your horizontal asymptote will be y equals 2 over 1 or 2. Okay, so you take the both coefficients and divide them by one another, the top divided by the bottom. How about the y-intercept? To find the y-intercept, basically you're trying to find where the graph hits the x-axis, you know. Sorry, the y-intercept is where the graph hits the y-axis. So anywhere on the y-axis, always the x coordinate is 0. So therefore, if I want to find the y-intercept, all I need to do is just make the x value 0, and then I'll be able to solve for the y-intercept. So therefore, y equals 2 times 0 in the equation on top there over 0 plus 2. So now that's 2 times 0 is 0 minus 1 is negative 1, and 0 plus 2 is just 2. So the y-intercept is negative 1/2. How about the x-intercept? So anywhere on the x-axis here, the y coordinate is 0. So if you're finding the x-intercept, all you need to do is just make y 0 and solve for x. So let's go ahead and do that. 0 equals 2x minus 1 over x plus 2. Now, what we need to do next is cross multiply the x plus 2 into the 0. And when you cross multiply all of that into the 0, it just becomes 0. So we'll have 0 equals 2x minus 1. Then just move the negative 1 to the other side. 1 equals 2x. Divide both sides by 2, and you will get x to equal 1/2. So therefore, the x-intercept is 1/2. Now, since we have all this information now, let's just go plot everything that we know. So we know the x-intercept is at 1/2. So as you see, that's 1 there. So 1/2 is right there. Also, we know the y-intercept is negative 1/2. So it's right there. They're very close to one another. And after that, we look at the horizontal asymptote, and we agreed the horizontal asymptote is at y equals 2. So y equals 2 is right here. So you just have a horizontal line or dotted line to indicate that's an asymptote. An asymptote is what? An asymptote is that dotted line that the graph gets very close to but never touches. Okay. And then your vertical asymptote. Your vertical asymptote is at y. The vertical asymptote is at x equals negative 2, and x equals negative 2 is right here. And that's your vertical asymptote, is also dotted line that you get very close to, but you never touch. So here on this side right here, I have these 2 points, and I have my horizontal asymptotes and vertical asymptotes that I know I'm going to get very close to, but I never touch. So all you need to do, just connect these points and then get very close to the vertical asymptote, and also you get very close to the horizontal asymptote, and that's what you get. On this side here, you don't have points, so but you're gonna get something similar to this on this other side. So if you want to do points, then you could just sub in a few numbers. So you could always go and do a table of values, X and Y, just because you want to have few points on the other side. So let's say we make X, let's say -4. So if we make X -4, then we have 2 times -4 minus 1 over -4 plus 2. That 2 times -4 is -8. That's -9. -9 divided by, that's going to be -2 on the bottom. So that's going to give me 4.5. So therefore, -4 gives me 4.5. Now I could go ahead and plot that. So -4 is right here, and it's 4.5. So I have a point right there. And honestly, all you need is 1 point on the left side of the vertical asymptote, and then you know you're going to have that kind of graph. You're getting very close to the asymptote, but you never touch it. So here you don't really cross the asymptote, it's just drawing there, you get very close to it, but you never touch it. And that's how your reciprocal function or rational function graph looks like. So that's basically it, you know, vertical, horizontal asymptote, find your x-intercepts, y-intercepts. Hopefully that gives you enough points to know how the graph looks like. If you don't, you could make another point on the other side of the vertical asymptote to find another point on the graph to tell you, you know, you're here. So you're going to get very close to the vertical asymptote, and you're going to get very close to the horizontal asymptote. If the point ended up being here, then you'll be doing this, because the asymptote is something that the graph gets very close to, but never touches. However, in this case, you have this right here and this right here. It looks like it has a point symmetry, because at this point, it seems like the graph is mirrored right at that point. And that's how you graph some of the reciprocal functions. As always, thanks for watching. Till next time, bye-bye. Remember, at the end of this video, I'll have a link to solving rational functions. So you might want to invest a little bit of time and watch that video